So page 24, okay, it looks like this. I'll be coming by and picking up your... You should have received the booklet that we're going to start most likely tomorrow. I think I counted this morning. I think we have 46 days until it's that exam week or the final test week. That's all we have classes if you take away the long weekends and the in-services. So hang in there. Type 2, fencing question. This is on page 24, okay? These types of questions will usually ask for dimensions. I will highlight this part here. Start with a diagram of the area to be enclosed. That's probably the key thing with this type of question. You can't just jump to this chart. You have to do a little diagram. They usually ask for dimensions to get the maximum area that you can fence in. So you'll have a certain amount of fencing available, and there's a way to figure out the dimensions that will allow you to fence in the biggest area possible, right? So this type is more challenging than other. This is the most challenging, folks, just so you know. It will not give you a starting point for your table. That's what makes it a bit more challenging. So add this to your study sheet. You need to read the question carefully and create a diagram, right? Create a diagram before you create a table. Here are some examples. There are some examples, not all. You just have to read carefully. Got it? So let's say the first step is create a diagram. So you read the question and it's clear to you. They're always rectangular, by the way, always. So in this scenario, right, you're fencing in a rectangular area and it's just a rectangle. So watch this. The perimeter in this case would be 2L plus 2W. 2L plus 2W. I'm going to move this up a bit. In this case, watch this middle case. The question will tell you that the area you're enclosing is next to an existing structure. So let's say there's a shed, there's a river, something is on this side where no fencing is required. So then you only need to fence in these three sides here. Okay, so in this case, the perimeter would be just L plus 2W, because the perimeter for us is the fencing that we need to close this up. Okay. Let's say this is a scenario, a third scenario, right? You're a farmer perhaps, and you're trying to make enclosures to separate sheep from goats, from chickens, right? You need a bunch of just enclosures. So let's say you want 1, 2, 3, 4, 5 enclosures, right? 5 enclosures, right? What would be, how much fencing would you need in this case? You would have to cover, how many lengths are there? There are 2 lengths, right? This side and this side here. So it's 2L plus how many W's? 1, 2, 3, 4, 5, and 6. Okay. So depending on the scenario, that's how your perimeter, right? This is fencing. This would be really fencing available. Right? We're gonna go like this, and we're gonna go like that. So that is basically how much fencing is available to you. Or you can spin it a different way, how much is required to complete this project. Keep in mind, Let's say this third scenario, because I just can't do them all. This could also have been built next to an existing fence, right? Let's say there's already a long fence and you just want those enclosures along that fence. In that case, you would not need to worry about the fencing on that one side, right? So this equation would amount to just L plus 6W, right? So what I'm trying to do here is I'm trying to let you see that depending on how the question is worded, your perimeter equation will change, okay? So just read carefully. It's really not like it's pretty easy to figure out what's happening if you read the question. Like they're pretty explicit as to don't fence in this one side, right? So there we go. Write out the equation of the perimeter or area depending on what you're given. Most of the time it's perimeter, okay? Third step, isolate for length or width using the equation in step 2. I usually isolate for length. That's just me. That's what I do. So looks like this. L is equal to something, right? I usually have L on its own and everything else on the other side. Then fourth, create a table like this. Okay, so you have length, width, and area. It's almost like items, cost, and profit, right? Same thing there. So length, width, and the area. And notice that the area is always length times width. It's always length times width. Multiplying these two will give you the area that you're enclosing. So watch this. This is perhaps a little, this is where it gets, let the dependent variable be 100, 200, or 300, right? This is important here. Or 50, 150, 200. And you can really choose what you want to do, but we just let it be something. And I will show you that in a bit. And then fifth, perform a regression using quadreg. Make sure your resulting equation does not have a equal to 0. I'm telling you that every time, because that would be a linear equation. You can't have that. It has to be quadratic. Okay. What are these two graphs here for? If you have, right, if you put length into L1 and area into L2, okay, then obviously this would be length, units, could be feet, yard, meters, you name it. And this would be the area. It'd be units. What's so special about units when it's area? It's units squared, right? Let me zoom into that a little bit. Right, and let's say you put the width into L1 and the area into L2. Notice that area always goes into L2. Then you have obviously width and unit, and you have area and units squared. Okay. So that's the only difference. We're still talking, just like the profit was the same, there's only one maximum profit that can be had with this scenario. Same with here. So this would be, right, maximum area. And same here, that would be the maximum area found at the top, which we call the vertex. Okay. So here you would find what length would give you the maximum area, and in this scenario, what width would give you the maximum area. Okay. let's dive right in and try an example. So much fun, eh? Regressions. So here we go. Let's so let's say you don't know what this is. I give you a quiz. All four types are here. Let's read it. You're a contractor and you have 600 meters of fencing available. Dead giveaway. It's like, oh yeah, this is a fencing question. Okay. All right, 600 meters of fencing available. Type 2, right? To enclose a rectangular area. It is adjacent. Adjacent means next to an existing garage, so no fencing required along the outside. And obviously the ultimate task is to find how can you maximize that enclosed area without having any fencing left over, using it all, and you want the biggest space fenced in. Sketch a scenario. I will say, okay, the rectangular, it's a rectangle that you're fencing in. One side is not fenced in. Which side should you be picking? I will tell you, always pick the length. Okay, always make the longer side the one that doesn't require fence. Okay, so that's kind of how I show that no fencing required. So all you need is this one length on this side and these two widths on either side there. That's it. B, write the equation relating the dimensions and the perimeter. So this is where you start the following way. The perimeter is L plus 2W. The 600 meters is going to be put in for the perimeter. So you're basically saying, hey, if I would have 600 meters of fencing available, that would be equal to L plus 2W. By the way, most of the time I walk you through it. So those steps are there, but I would still say have them on your study sheet, but most of the time it's A, B, C, D, like it walks you through it. Before you create the table, you need to isolate either length or width. Okay? I will isolate either L or W. Okay? If I have L here, if L is on the right side of the equal sign, 2W will come over to this side. And what happens to the 2W when it crosses? It turns into a negative, yeah? So there it is. I'm going to use this one. This is the one where I ask you, hey, isolate for one of them. I've isolated for length. This is IPR, and I apologize. It doesn't go away. Which one of these two is your dependent variable? L is your dependent, yes. Okay. So in this case, because L depends on what W is, so this is your dependent variable. And I just noticed that I made a mistake. That's what happens every once in a while. I'm going to go back one page and just double check. This is not supposed to say dependent, it's supposed to say independent. Like if you go back to 24, that fourth step, it's supposed to say independent variable. Let the independent variable be 100, 200, 300, or so forth. I apologize for that. It's a very big deal. It's 2 letters, but a big deal, right? So if this is the dependent, then this is the independent. And I don't have a lot of room, so I'm just going to go like that. So watch this. I tend to just go make the first length The second column is my width, and this is area, which is just length times W, right? You know when it's fencing, it'll be length, width, area. And so watch this here. The independent variable is W in this case, right? You let that be something, anything you want. I tend to go 100, 200, 300. Sometimes I go 50, 100, 150. It really doesn't matter. To be honest, 1, 2, 3 would work. It really doesn't matter. You just plug in something and figure out what L is. Sometimes you get a negative. It doesn't matter. I don't like negatives, so I keep this number. I turn it into like something smaller, maybe 10, 20, 30 or something like that. Let me actually check my notes. I went 10, 20, 30. Let me just check real quick. I think I will do the same. Just to stay, you don't need to go that big. So let's just go 10, 20, 30. I apologize. Make up your mind, right? So anyways, you identify the independent variable. You let that be something, okay? I will say this, you choose, okay? And there I will say you choose, because those 10, 20, 30, you're gonna have to know where did I get them from. And in my key, you'll get different values for it. Anyways, now that we have this figured out, we need to figure out what the length would be under each circumstance. And I should have left you a bit more room, but it is 600 minus 2 times 10. In this case, right? L is 10, so W, sorry, so I plug in 10 there. In this circumstance, it would be minus 2 times 20. And in this circumstance, it would be minus 2 times 30. And we're going to run out of time. C'est la vie, right? That's how it is. Anyways, let's do at least come up with the equation. So 600 minus 20, that's 580. We can do that. 600 minus 40, that's 560. 600 minus 60, that's 540. And then we just figure out this area part. Technically, after I do this part, everything else is the same as before. So let's type this into I'm just going to stop there. That's it. To be continued. I'm wondering, should I just, what I'm going to tell you is just review yesterday's stuff. I assigned pages 14 to 17. So if you still need to do that, then do that, okay?